Hello everyone, in this video I'll talk about the Hamiltonian equation in self-consistent field method. So, what is quantum mechanics? It is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and also subatomic particles. The aim of the quantum mechanics is to solve the time-independent Schrödinger equation, which the Hamiltonian operator produces the evaluation of energy. The self-consistent field method that will be discussed here is actually based on the Hartree-Fock theory. It involves the selection of an approximation one-electron wave function, which is the Hamiltonian equation, that will be solved to obtain an accurate set of orbitals, and the process of selecting and solving the equations will be repeated until the values obtained are converged. Hence, the multi-electron wave function with n numbers of electrons can be approximated by the product of n one-electron wave function. As stated just now, the process of evaluation involves the approximation of one electron wave function where each electron is described by an orbital, and this method is called the molecular orbital approximation. The basis set used is shown as this wave function where Cij is the coefficient, and we use the simplification of the independent particle models where the probability density of an electron doesn't depend on the other electron. So, the independent particle models actually describe that the motion of one electron is independent of the dynamics of all the other electrons, and the interactions between the particles are approximated by either taking the most important of the interaction and neglect all the others interaction, or it takes the average of all the interactions. The operator we use here is the Hamiltonian operator, where the equation is shown here. On the left-hand side, the first term describes the kinetic energy, while the second term describes the potential energy. And on the right-hand side, the eigenvalue obtained will be the E, which is the energy. And to express the wave function here, the selected determinant is used due to the multifermionic of the spin of electron according to the Pauli's principle, where the spin quantum number is positive negative 1/2. As shown here, the form of the Hamiltonian operator has more terms involved, which that includes the kinetic energy of electron and also the kinetic energy of nuclei, and it also involves the potential energy between the electron-nucleus interaction, electron-electron interaction, and the nucleus-nucleus interaction. And then, the variational principle of self-consistent field method and Hartree-Fock method is also used to find the best wave function for our approximation. According to the variational principle, it states that the true value of the energy in the system is always the lowest value, and if the E0 is the exact ground state energy of the system, then the EI, which is calculated from the approximation of the Hartree-Fock method, is always greater or equal to the true energy value as stated in this equation, where the EHF is the approximation value and the E exact is the ground state system. How to use the self-consistent field method? First, select a set of n basis functions. Second, determine the value of all Hij, which is the resonance integral, and the Sij overlap integral. Third, use the circular determinant equation to determine the various energy values EI, and then from all the EI values we solve the differentiated form of energy equations to get the value of the coefficients. In short, SCF is an iterative method that uses the linear combination of atomic orbitals to construct the molecular wave function. It functions by solving the Schrödinger equation to help us to obtain a more accurate set of orbitals until the result is converged, and by that we can approximate the multi-electron, which is n electron wave function, by using the product of n one electron wave function, which is the Hartree product. Thank you for watching.